Okay, so today we're doing section 4.4, properties of rational functions. And our objectives are to find the domain of a rational function, find the vertical asymptotes of a rational function, find the horizontal or oblique asymptote of a rational function. So first off, understanding what a rational function is. A rational function is a function of the form f of x equals p of x divided by q of x, where p of x and q of x are polynomial functions and q of x on the denominator cannot equal 0. So we know that in a fraction, the denominator cannot be 0 or it is undefined. Okay, so when we want to find the domain of rational functions, we know the domain of a rational function is the set of all real numbers except for those for which the denominator q is 0. So we know that the denominator can never equal 0. So when we want to find the domain of functions, we want to see when is that denominator going to equal 0. So for this first one, we're going to look at the denominator x plus 2, and we're going to set x plus 2 equal to 0. And we know that when we move it over, x equals negative 2. So that means the domain of this function is going to be all real numbers. Remember that R is the symbol for real numbers, except when x equals negative 2. So the way we would write this out in notation is we would put the x with the bar, and on the other side of the bar we would just put x equals negative 2. Or I'm sorry, x cannot equal negative 2. So this notation means x is all real numbers except when x cannot equal negative 2. So for this next one, we could reason this out. We could say any number I put in for x is going to be squared. And I know anything that's squared is going to be positive. And by adding 4, that means we're never going to have a 0 in here. Okay, so in this case, the domain is going to be all real numbers. Okay, and the reasoning is what I just stated. No matter what is put in, for x squared makes it positive. And therefore never equals 0. Okay, the only difference is if we had an equation like this and we said x squared minus 4, well, I know that factors out into x plus 2, x minus 2. So there would actually be 2 zeros on this. But because it's a plus 4, it doesn't factor out anymore, and the number is always going to be positive. So for this next one, to figure out what the zeros are, we want to take that 3x squared plus 5x minus 2, and we want to set it equal to 0. So what we're going to have to do is we're going to have to factor out our polynomial. So I know one side's 3x, the other side's x. There's a plus and there's a minus, so I'm going to need to multiply 3 times 2. And the 6 has to be positive. So that means when we look at this, we would have 3x minus 1 equals 0, x equals 1/3, and x plus 2 equals 0, x equals -2. So our domain is going to be x except when x cannot equal 1/3 and x cannot equal -2. Okay, horizontal asymptotes. A horizontal line in which the graph approaches. So the graph of a function may intersect a horizontal asymptote. So basically that's like if we had the graph and we had this horizontal asymptote here, you might have the graph like this to where it approaches this line, but it never touches it. And I did the wrong direction, sorry. The horizontal asymptote goes crossways. So it would be the line this direction. So the line approaches it, but never crosses it. Okay, that is a horizontal asymptote. So there's 3 rules to know. If both polynomials are the same degree, divide the coefficients of the highest degree. So for example, on this one, if we had f of x equals 2x squared plus 3 divided by x squared minus 1, the degree of the function are the 2 highest, and this 2 is the same. So the highest degree on both the numerator and the denominator is the same. So the horizontal asymptote, and I'm just going to use HA for that, would be 2 divided by 1, or just 2. So it would be x equals, not x equals, y equals 2. Sorry. Y equals 2. If the polynomial in the numerator is a lower degree than the denominator, the x-axis, or y equals 0, is the horizontal asymptote. So, for example, f of x equals 2x plus 1 divided by 3x squared plus 4. The numerator up here has a lower degree than the 2 on the bottom. So your horizontal asymptote is just going to be y equals 0, or you could say the x-axis. And the last rule is if the numerator is higher. So for example, if f of x equals 5x cubed divided by 2x squared plus 1, 3 in the numerator is higher than the highest degree on the bottom, 2. So for this one on the horizontal asymptote, there is none. And we're going to do a couple more examples on that. All right, here's a couple of examples on the horizontal asymptote. So what we want to look at is, first off, we want to look at the numerator degrees, or the denominator. So this one has a degree of 2, and the bottom one has a degree of 3. So in this case, the numerator degree is lower. Okay, so the numerator degree is lower. So when we look back at our rules, if the numerator is lower, then the x-axis, or y equals 0, is our horizontal asymptote. So our horizontal asymptote is y equals 0. Looking at the next example, the degree for the numerator is 3 and the degree for the denominator is 2. So in this case, the numerator degree is higher. And we said that if the numerator degree is higher, then there is no horizontal asymptote. So those 3 rules we went over, you really want to, look at those when you're solving these. And the last example, the degree at the top is 2, the degree on the bottom is 2. Those are the highest degrees. So the numerator degree is equal, or is the same as the denominator degree. So in this case, the horizontal asymptote, you would take the numerators, or I'm sorry, not the numerators, the coefficients in front. So the coefficient in front of x is 1, and the coefficient in front of the x squared on the bottom is 2. So those are the 2 that we want to use, and we want to put them as a fraction. Y equals 1/2.